Everybody with me? 3.1. All right, we are going to talk about exponential functions and their graphs. On your quiz on Friday, you guys are going to be given an exponential function. I'll show you in a second. And I'm going to ask you what's the domain, what's the range, what's the horizontal asymptote, what's the y-intercept, and then you're going to have to graph it. And I'm going to talk about solving one-to-one equations, and then we're going to talk about compounds. So we're going to go over all that right now. All right, an exponential function with the base of a is denoted by this. Guys, look at this. This is an exponential function. Where is the exponent? What's in the exponent, I should say? A variable, all right? An exponential function has a variable in the exponent. The big number here, I'll call it the big number, is called the base. It's not always a big number like 10 or something like that, but it's visually larger. Okay, it says where a is greater than 0, meaning you could have a function that's like this, 3 to the x power, 7 to the x power, 1/4 to the x power. This is the base. You will never have like -2 to the x power. That's not considered an exponential function. You might have a negative out in front of something, which means a reflection in that sort. We'll talk about in a second. But your base itself will always be a positive number. It'll either be a whole number, bigger than 1, or it'll be a number between 0 and 1. Those two things mean different things. I'll show you that in a second. But an exponential function has an exponent that is a variable. This function starts out slow and it grows or decays. We'll show you in a second very quickly. COVID is an example of an exponential function. Like one person had it, then 3 people had it, then 150 people had it, then 275,000 people had it. It grew quickly. All right, on WebAssign, you will have questions like this. You will not have this on your quiz, but on WebAssign you will. This is just practicing with your calculator. All right, it says evaluate the function, round your answer to 3. This is saying 0.5 raised to the 1.2 power. Some of you have an exponent key that like puts it in a little box. Some of you have something this is called a caret. It's like the top of an arrow. That's how you raise something to a power. So just practice with that. This one would be 150. You can type it in just like this, times 2, and then you hit the caret button, and then you put in -2.5. And again, practice with your calculator. That's what I want you to do. Your WebAssign is not due until Friday morning because I want you guys over the next couple days to play with it. But you're just practicing this, just entering it into the calculator. This is a very important slide. I'm going to go through each thing. All right, you're going to be asked domain, range, vertical asymptote, horizontal asymptote, all that stuff. You need to understand where this comes from. If you look at this slide, number 1, the first thing it says, the domain of our exponential functions is what? All real numbers. There are no restrictions. You can put in all the negative numbers. You can put it on all the positive numbers. You can put in 0. So for all of our exponential functions that we're talking about, guys, your domain is -infinity to positive infinity. Do you see that? Yes? You're always going to have a y-intercept, right? Number 2 is talking about the y-intercept. How do we find y-intercepts? We're going to plug in 0 for x. So when I say to you guys, okay, here's the function. Tell me what the y-intercept is. How do you do that? You're going to plug in 0 for your x value into the function. You're going to be able to find the y-intercept. You're going to be able to tell the direction if your graph is going to be growing, whether it's increasing from left to right, or if it's decreasing from left to right. I'll show you that in 1 second. You're going to have something called a horizontal asymptote. We already talked about these horizontal asymptote. It's going to be a y equals, and it's going to be a boundary line that your graph gets really, really, really close to but doesn't touch. Your range is going to be dependent upon your horizontal asymptote. There are no vertical asymptotes in exponential functions. If that's on WebAssign question, it says, what's the vertical asymptote? Your answer is none. There aren't any. There's nowhere that this is going to get to a vertical line and not touch. But I want you to notice these two graphs. Okay, do you guys see the blue graph and do you see the pink one? All right, if we look at the blue graph, if I read this from left to right, starting over here, what is this graph doing as I follow it, my pencil on it? It's increasing, okay? Notice that it says that the base is greater than 1. It's a number bigger than 1. You're going to have an increasing. It's called an exponential growth. It's getting bigger. If you follow this graph from left to right, what is this graph doing? Decreasing. Notice what the base is. It's between 0 and 1. Just because it's a fraction, guys, it could be bigger. Like 3 over 2, that's bigger than 1. But if you have 1/2, 1/3, 0.5, your graph, you should be able to visualize in your mind what it's doing. It's going to be decreasing because the base is between 0 and 1. Just understand that. All right, you guys with me? Okay. We're going to put numbers to this in a second. It's going to make sense here. So if you have a graph like this and your y equals 0 is your horizontal asymptote, that means your graph is going to get really, really, really close to it but not touch. So it's not going to be included in the range. With our parabola, it was included with the range. With your exponential functions, it's not. So let's go over some examples here. Look at these two problems. Look at A and B. How do they look similar? They both have the same base. Good. Very good. How do they look a little different? One of the exponents is positive and one of them is negative. So let's just evaluate this real quick. All right. I'm going to tell you to go ahead and evaluate, and let's use -2 to +2. If I plug in -2, what's 3 to the -2 power? 3 to -2. Well, when I write that, how do I write 3 to the -2? What happens when you have a negative exponent? Uh-oh. If I have 3 to the -2 power, guys, how would I rewrite that so my exponent is positive? Tell me. 1 over 3 squared, so it's 1/9. Whenever you have a negative exponent, if it's negative in the numerator, put it in the denominator, or vice versa. So what's 3 to the -1? 1/3. What's 3 to the 0 power? 1. What's 3 to the first power? 3. What's 3 to the second power? 9. Okay. So at -2, I'm at 1/9 there. At -1, I'm at 1/3. At 0, I'm at 1. At 1, I'm at 3, and then at 2, I'm at 9. So up here, so my graph looks something like this. Do you see how it starts off slow but grows quickly? You guys see that? All right, if I come over here and I do the exact same thing, I'm going to evaluate the exact same way, -2, -1, 0, 1, and 2. If I plug in -2 here, I have -2. Well, what's the negative give me? Positive. So what's this going to do? It's just going to reverse all the way down. This is going to be the exact same numbers here, but opposite direction. So I have at -2, I'm at 9. 7, 8, 9. And then I'm at 3. And then we're here, we're here, we're here. So it's going this way. Why did it flip? Because there's a negative where? In the exponent, right? There is a negative in the exponent. But you guys see the left-hand side is increasing, the right-hand side is decreasing. Now, just looking at this, I could tell why it got really close to the y-axis where x is 0, but didn't touch it. And the way that you can tell what it's going to get really, really close to and not touch is what is being added or subtracted. Is there anything being added or subtracted to my function here? No. If it said +1, what would your horizontal asymptote be if at the end it said +1? Y equals 1. If it said -7, what would your horizontal asymptote be? Y equals -7. That is your vertical shift up and down. That's what's going to determine where your graph gets really, really close to but doesn't touch. So you're going to be asked domain, range, horizontal asymptote, x-intercept or y-intercept, all that stuff. You're going to be able to tell that mostly just by looking at it, but then once you plug in a table of values, you'll be able to see real well. So let's look at, what is the difference here? with these two? One's a fraction between 0 and 1, and one's a whole number, right? This is a decay. This is going downward, and this is a what? A growth. It's going to be increasing. Good. What are both of their horizontal asymptotes? 0. Good, JC. What's being added or subtracted to the end? Nothing. So your horizontal asymptote would be 0. What's your domain for both of these? Negative infinity to positive infinity. What's the y-intercept for both of these? Plug in 0 for x. 1. Good. So a lot of the stuff that you guys need to identify, you're going to be able to do just by looking. And I'm going to go over some examples here in a second. This is a really important slide. All right. All of this stuff you guys have seen before. If I gave you this, you don't have to write this down, but if you want to, you can. If I said this. Do you guys agree with me that this is a function and it's a parabola? Yep, because it's squared. Now, if we move left to right, you guys can tell me all of the transformations. Since there's a negative out in front, that means my parabola is going to flip which way? It's going to down. So this is going to reflect over what? Over the x. All right, I have a whole number 3. Is that going to stretch or shrink it? It's going to stretch it vertically or horizontally. Is it inside the parentheses or outside? It's going to vertically stretch. Good. This plus 7 at the end, what's that going to do? Hold on one second. Think about at the end, what's it going to do? Up or down? What happens inside here? It's the opposite. It's going to go right forward. All right, that's a review from when we did parabolas, but also you guys from Algebra 2. I know you guys talked about transformations and stuff. Anything that's outside the parentheses has to do with vertical, like up and down, add and subtract anything. If you're multiplying in the front, it's going to be a vertical stretch or shrink. If you have anything inside the parenthesis, that's going to be the opposite of what you think. That's going to affect your x. Yeah. I don't know why I wrote down. Thank you. Let's just make this a minus. Thanks. Make that minus 7. Now it's down 7. So the exact same rules apply here. Do you guys see here? Here's your exponential function, b to the x, whatever to the x. Do you see how you're adding or subtracting something to the end of the function? That's going to move it up or down. That is going to be your horizontal asymptote. Whatever is being added or subtracted is your horizontal asymptote every single time. If you notice here, where is the transformation happening? Is it inside with the x? Right? Just if it was with the parentheses. So this is going to be left or right, and it's the opposite of what you would think. If it's plus, it's going to go left. If it's minus, it's going to go right. Same exact things that you guys have talked about before. If you have a negative out in front, that's going to flip over x. And if it's with the x, it's going to be over y. And then your shrinks and your stretches. If it's vertically, it's going to be out in front. The vertical stretch or shrink. And if it's with the exponent, it's your horizontal. And again, it's the opposite of what you think. So you can tell a lot about your exponential function just by looking at the equation itself. You can tell if it's going to move left, right, up, down. If it's going to reflect, anything like that. But again, you're going to be plugging in table of values so you can see exactly what the shape of your graph looks like. But if you had something like this, if I had f of x equals negative 3 to the x plus 1 minus, or plus 4. All right, you guys should be able to visualize what this graph is going to do. First of all, where is the horizontal asymptote at what? Y equals what? Y equals 4. It's always what's added or subtracted. So just looking at this, your function is going to reflect over what? Reflect over the x. It's going to move which direction? left 1, and then where? Up 4. So you should be able to envision, you should be able to visualize what is happening with your graph before you even start. If I said to you now with this equation that I just made, what's the y-intercept? What would you plug in for x? Plug in 0. So think about this. If we're going to find the y-intercept, I'm going to plug in 0 right here. Well, what's 0 plus 1? What's 0 plus 1? 1. Okay, so what's negative 3 to the first power? Negative 3 plus 4. So your intercept would be there. What's the domain of this function? Negative infinity to positive infinity. You're also going to have to tell me the range. You could tell me the range right now, or you could wait until you graph it. But your normal function, since this is a whole number, would be a growth, good. But that negative in front means it reflects it, so it's really going to go like this. So your range would be from negative infinity to what number? Your range and your horizontal asymptote go together, always. But again, you are going to have to graph this, so you guys will be able to see exactly where your graph exists, that sort of a thing. But this is all tied into all the stuff we've done before with asymptotes and intercepts and domain and range. Everything goes all together. So we're going to practice this. You guys are going to practice for the next few minutes and then for the next couple days. Look at these two functions. Do you see them? F of x and g of x? All right, so let's talk about this. Tell me, what's the domain for g of x? All real numbers, negative infinity to positive infinity, right? In interval notation, all right? What is the horizontal asymptote? Where is this graph going to get really, really close to but not touch? Y equals 3. It's whatever's being added or subtracted. All right, what is the y-intercept? When I plug in 0 right here, what is 4 to the 0 power? 4 to the 0 power, guys. What's anything to the 0 power, guys? 1 plus 3 is 4. Okay. Do you see a negative out in front that's going to make this thing flip over? No. So that means it's just going to be like a normal little growth kind of thing. So what is your range? It's going to be based upon your horizontal asymptote. Is it from negative infinity to 3? Or is it 3 to infinity? It's 3 to infinity. It does not include the asymptote. It gets really close to it, but doesn't touch it. So then if you were going to... Because it was flipped over. There was a negative in front. But again, you'll see that when you go to graph it. But on WebAssign, you're going to have a couple where you have to pick the graph. So instead of plugging in table of values, you can say, oh, okay, there's a negative in front, so it flipped over the x. It moved to the right 3, something like that. You'll be able to identify. We're going to look at some of the ones from WebAssign here in a second. I just want you guys to see all this. Where is this one going to move? To the right 2. Good. If it was at the end, it would be down 2. But since it's with the exponent, it's with the x, it's going to go left and right. It's opposite of what you think. What's the horizontal asymptote for this graph? 0. Y equals 0. What would the intercept be? We would plug in 0. So we get, right, 4 to the negative 2. It would be 1 over 16, something like that. But all of the stuff that you guys need for the quiz, you're going to be able to just fill in, I promise. We're going to go over it more on Thursday. All right, you're going to be asked a couple questions to solve using the one-to-one property. And some of you are like, oh my gosh, guys. Okay, look at this. Do you see here how the left-hand side equals the right-hand side for your bases? Yes? Both of the bases are the same? All right, this is a special property that some problems allow themselves to be written in different ways, or rewritten, I should say, to where the bases are the same. If you can do that, this is a really easy thing to do. I will give you some problems that say solve using one-to-one, meaning this can happen. What's going to happen is you want to get bases to be the same. And we'll talk about that in 1 second. This I cannot impress upon you enough. Anything raised to the 0 power is what? 1, okay? Part of your quiz will have a calculator, part of it will be non-calculator, so it's going to be important to remember these little things. Solve using the one-to-one property. What that means is you want the bases on the left-hand side and the right-hand side to be the same. So if I look at letter A, is there another way I could write 3 to a different power that could represent 3? No. It's just 3 to the x minus 2. Is there another way that I could write 9? I could write it as 3 squared, right? 3 to the second power. Do you guys notice what we just did there? We created an equation where the base on the left-hand side is the same as the base on the right-hand side. Once you do that, you can cross the bases out and set the exponents equal to each other. If I solve this, what do I do to both sides? I add 2, right? So I get x equals how much? 4. What can I do with that number? Yeah, plug it back in. Check that. If I plug that in there, what is 4 minus 2? 2. What is 3 to the second power? 9. So 9 equals 9. When I guarantee you, when I give you these problems on the quiz and it says solve using one-to-one, you absolutely can make the bases the same. All right, let's look at B. This is a little different. Diego, what are you doing? If you don't want to pay attention, just don't pay attention. What's another way I could write 1/2 to where it doesn't have a fraction? It's not a fraction. This is 2 to the first power, right? What's another way I could rewrite that? Okay, 0.5, yeah, that would be a decimal. But what could I do? How could I move this up here? 2 to the negative 1 power. It's the same thing as saying 1/2. That x did not go anywhere. It's still right there. So I have equals 16. All right, so this is just 2 to the negative x. All right, fine. Can I rewrite 16 that has a base of 2? How could I rewrite 16? 2 to the what power? 2 to the 4th power. Are my bases on the left-hand side and the right-hand side the same? Yes, so this becomes negative x equals 4. So what's x equal? Negative 4. Good. Question.
Couldn't you also do 1/2 of the negative 4?
Yeah. If you see it like that, yeah.
Is it both when you get correct?
Yeah, that's fine. Danny, question?
Yeah, I don't understand how you did the first one.
How I did this one?
No,
The first step here?
Yeah.
As soon as you see a fraction, like if you had 1/4, you can rewrite that as a whole number because there's a 1 here, right? As 4 to the negative 1. As soon as you have, if you want to bring something to the, like from the denominator to the numerator, your exponent just becomes negative, or the opposite of what it was. Like if you had 3 to the negative 2 power, that's the same as saying 1 over 3 squared. As soon as you bring it down to the other side, like from the numerator to the denominator, the exponent becomes the opposite sign. Yeah, sure. All right, let's look at this one. Is there anything I could do? Is there any way I could change 6 to raise it to a power to make it a 1? 0. It's the only way you could do it. Guys, if you get this on a quiz, please don't make that mistake that you're like, it doesn't work, undefined. Yes, it does. What is anything raised to the 0 power? 1. All right, so make sure if you have something like this, the only way that that could be a true statement was if your exponent was 0. So when they say solve using the one-to-one property, that means get the bases to be the same. You absolutely can. Some of you will see some of these a little differently. Ariana saw B differently than I did B, which is fine. Just a lot of us don't like to deal with fractions. So in order to get rid of that fraction, when you moved your denominator to the numerator, the exponent became negative. All right, lastly, over this last little bit, well, I'll talk about this for a second, then we'll go to interest. On your calculator, guys, there is an e to the x button. It's on the same button that has ln on it. Natural log, and then there's e to the x. They're on the same button. They're reciprocals of each other. We'll talk about, or inverses of each other. We'll talk about that a little bit more next week. But this is a programmed number into your calculator. It's like when you hit pi at 3.1415. When you hit e to the x, it's 2.71828. It's an irrational number. So you're going to have problems where you have to, on WebAssign, not on your quiz, but on WebAssign where you have to evaluate like e to the x, where you have to plug in. All this is you hit the e button and this will come up, and then you would just hit 4.2 and you plug it in. Here you would hit 125, then you hit e, and this will come up, this little caret thing, you hit 0.05 times 30. Might have to put this in parentheses, something like that. This is something I need you guys to practice over the next couple days so you know how to use your calculator. Come in on Thursday and say, I kept getting this answer wrong. I need you to help me with that, because you have to know how to use your calculator. If you guys just show up on Friday because you grabbed somebody's calculator on the way in, that's not going to be very helpful to you because you're not going to know how to use it. And I'm not going to answer questions on the quiz on how to use your calculator. You just need a scientific, doesn't have to be graphing or anything like that, nothing major. All right, last thing I want to talk about is compound interest, all right? We're going to talk about continuous next week. We'll talk about the continuous next week. This is just a little formula for it. It's not that big of a deal. We'll talk about it later. But this is what I want you guys to focus on right now. All right, this is the compound interest formula. This is how banks work, that sort of a thing. You guys are going to be given all of the information, and you have to figure out what the amount is left over, or what has accrued, that sort of thing. When you see the word principal, that's the initial amount. What does that mean? What does the initial amount mean? What you start with, right? You're at the bank and you put in $15,000, $10,000, $1,000, whatever. You're going to need to identify the interest rate. It has to be a decimal. Talk about that in a second. You're going to talk about the time. It's going to be time in years. And then N. This is how money is compounded. All right, this is all calculator stuff. This is the part of the quiz I'm going to give you, and I'm going to say, here you go. And it all has to be done in the calculator. You cannot do this by hand. I need you guys to practice this over the next couple days so you can come in and say, I don't know how to do this. I keep getting it wrong, that sort of a thing. It can be a little tricky, so I want to make sure you guys see it. First of all, if I give you an interest rate of 3.9%, is that a decimal? No. There's a decimal in it, but that is a percent. How do you know it's a percent? Because there's a percent sign on it. So how do I make this into a decimal? What do I do? We're going to divide by 100. You're moving the decimal place over how many? 2. So this was really 0.39. It's very important, guys, that you do that before you put it in your formula. Because if you put it in as 3.9, your answer is going to be really, really, really off. All right, it's really important. We're going to do one example 2 different ways. I want to show you, and I want you guys to play with this. Yeah. Say it again. Because when you're given the interest rate, you have to change it to a decimal before you put it in the problem. Yeah. This is, yeah. It's how the money is compounded. All right. This is your N value. You guys need to know what these words mean. If you have semi-annually, what does the word semi-annually mean? How many times a year? Twice. Semicircles in how many pieces? 2, right? If you see quarterly, how many quarters are there in a dollar? 4. Okay. If you see monthly, how many months are in a year? 12. Continuously, we'll talk about next week. This is it's a different formula. But we'll talk about it next week. You guys don't need it right now. You need to know what these words mean. Semi-annually, quarterly, monthly. What about if it says weekly? How many weeks are in a year? Everything's based on a year. How many weeks are in a year? 52. Okay, good. What about if it said daily? How many days? 365. Okay, good. Whoops, not a 2. 365. Good. So when I have a problem like this, right, you guys, you have your interest formula. You need to know the interest formula. I'm not going to give that to you. You need to know it. But you need to identify all the pieces of the problem that they gave you. What is the initial amount that you started off with? What did you go to the bank and say, hey, I have this, I want to put it in? 15,000. Good. That's your principal. That's what you started off with. So read through your question. The next thing says at 2 years, for 2 years. So what is that variable in our equation? T. Good. So T equals 2. Good. So your interest rate is 3.2%. Is that what we're going to use to calculate? No. What are we going to use? 0.032. You have to change it to a decimal. And then N. This is the value that's going to change. We're going to do B and C. We're going to do these two. And then I want to open up WebAssign just to have you guys look at it. What is the N value I'm going to use for B? If it says compounded quarterly. 4. And what is the N value I'm going to use for C? 12. Okay, good. So when you set these problems up, I need to see what you put in your calculator. So you guys are going to tell me it's 15,000, and then I have 1 plus. What does the formula say? What's the formula? Tell me. R over N. So my R is 0.032 over N is 4. And then I'm going to raise that to what power? What does it say? What are the letters that are in the exponent for your formula? N times T, right? So N is 4 times 2, which is 8. If you want to put in 8, that's fine. So my C, question C, is going to look exactly the same. I have 15,000, 1 plus, the interest rate is still the same. But what is my N value in letter C? 12. So then my exponent becomes, I'm going to raise it to the 12 times 2. Every time you do one of these interest problems, guys, I'll give you probably 2 or 3 with the same values to do either quarterly, daily, weekly, whatever. But your principal stays the same, the time stays the same, and the interest rate stays the same. The thing that changes is the N value, how the money is compounded. When you do this in your calculator, many of your calculators, you can just go left to right, exactly like you see it, but you need to put the middle fraction in a parenthesis. And if you leave this as 4 times 2, that needs to be in its own parenthesis. If you don't, your calculator raises it to the 4th power and then times that by 2. If you want to just say 4 times 2 is 8, that's fine. But if you just work left to right, plugging that in, 15, try. Those of you who have a calculator, try. There's 2 questions on your WebAssign that it's like, hey, do this. You guys need to try this. So when you come in on Thursday, you're like, I don't know how to do this in my calculator. I can't figure it out. That sort of thing, and I'll help you. But you're going to have a calculator part of your quiz that it's just like this. You guys just have to figure out the money. Now, do this in your calculator now, those of you who did it, and whatever you get, tell me. If you get some ridiculous number, that's okay. We'll figure out where you went wrong. But just try. All right, so Taylor got 15,000, how much? 987? 31, okay. Last period, somebody got like 52 million or something because she just input it wrong. No big deal. Anybody else get that same thing? Did anybody not get that? Come here, let me see your calculator. We'll look at it. All right, do the second one. See what we get. What'd you guys get for this one? Tell me. 15,990.02. All right, so I want you guys to look at this for a second. This is really, really, really important information. I'm serious. What did we start off with in each equation? 15,000. Okay, so look at this. You started off with 15,000 in each equation. Look at how much interest after 2 years you have. Is it a huge, huge, huge difference? No. Is there a huge difference between when you compounded monthly and compounded quarterly? No. It's a difference of $3. See that? When you guys are working these problems out, right? You plug your you work out, you went to the bank with $2,000, you had this interest rate over 9 years, and after 9 years you had $18 million. Does that make sense? No. If you plug this into your calculator and your initial is millions of dollars difference from what you have accrued over the whatever time I gave you, you forgot to change your interest rate into a decimal. or you forgot to put parentheses on something. Because when you guys are doing these problems, your initial amount and what you have accrued over the whatever given time I've given you should not be millions and millions and millions of dollars different. That's not how life works. That's not how bank works. So some of you are going to do this on the quiz and tell me there's not enough room in my calculator display. There's too many numbers. That means you did something wrong. So just check these things. Trying to give you guys little things. This should be a really easy quiz for you. It should be a good little bump for some of us. But you have to be able to use your calculator correctly.